Okay, in this problem, they've given us a function, and basically for part A, all they really want us to do is rewrite it in terms of x, which means get it by x by itself. So what we'll start with, we'll rewrite it. I'm actually going to leave it exactly the way it is. And I'm going to start by getting this out of the denominator by multiplying both sides by square root of x plus 1. That's going to give me y times the square root of x plus 1 is equal to 2. And the next thing I'm going to do is probably get rid of the square root by squaring both sides. Now you've got to keep in mind, you've got to square everything if you're going to do that. So if I square both sides, it's going to look like this and like that. Well, this is going to become y squared, and this is going to be x plus 1, but it's still being multiplied, so I got to show that. And then, of course, 4. Now I'm going to divide both sides by y squared because I'm trying to get x by itself. And then all I got to do is subtract the 1, and then the x will be by itself, and it will look just like what they wanted. So we're good there. All right, now in part B, what they want us to do is use what we just found and find the area of the shaded region, which is nice because they're basically telling us exactly what to do in this problem. So it's bounded by the y-axis. We, in fact, need our rule written in terms of y, and we just figured that out. So now all we've got to do is, well, we're going to integrate this and use the boundaries 2 and 1. The first step is going to be raise this y squared up and make it negative. And then when I go ahead and integrate that, I'm going to write the 4. Y is going to go up to -1, so I'm going to multiply by -1. And then, of course, the integral of any constant is just, I just make it a y, or in this case y, right? So now I've got the integral function. I put a box around it and put my boundaries. And then all I've got to do is substitute in the values. Wait a minute, not -1. I'm going to substitute in 2 for all my y's. And then what I'm going to do is I'm going to substitute a 1 in for all my y's. And then I'm going to subtract it. And when I do that, I'm going to find out that I'm going to get a -4 and a -5. -4 minus a -5 is equal to 1, and then that's going to be the area right there, 1. All right, now they want to take this shaded area and they want to rotate it around the y-axis. They want us to find the volume of it. Well, this is going to be very similar. All we're going to do is take that function that we started off with before when we were doing the shaded area, but now we've got to square it. And then we're going to multiply our answer times pi. So again, you got to be able to square a binomial. This is going to be 4y to the -2 squared is 16y to the -4, and then I multiply the two terms together and double it, and then square the last term, and that's that. So now all I can do is integrate, and I write 16. I give a gap y. I'm going to raise the -4 to a -3, multiply by a -1/3. And then I'm going to do the same thing here, -8, leave a gap. I'm going to raise the -2 to a -1, so I'm going to multiply by -1, and then that's going to be a y. So all I got to do is rewrite this by simplifying my terms. That's going to be my integral function. I'm going to put a 2 in there and a 1 in there. I'm going to make sure that I substitute in the 2 and the 1, and then I'm going to multiply those answers by pi, and then all I got to do is subtract them. And in this case, what it's going to do is it's going to give me 16/3 when I substitute in a 2, and it's going to give me an 11/3 when I substitute in a 1. And so when I do 16/3 minus 11/3, it's going to give me 5/3 or 5/3 pi. And then that's my answer for that. So once again, thanks for watching. I hope that helped.